Hello, IBSL2. Tonight's topic is day 4, and it's going to be a new topic for you. We're going to be talking about vectors in space, three-dimensional vectors. And for your reference, we're in the textbook at page 380. Also, I recommend going to our website and downloading the paper note. So go ahead and click on that and pause the video and print that out. There are a lot of formulas tonight so that you have less to write down as you're working. So go ahead. I recommend that. You don't have to, but it will save you some work if you take a minute to print that out. Okay, so hopefully you printed that out and you're back with me and you have all this on your page, except for a couple things that I've added. So the first thing to understand with vectors in space is now we have 3 dimensions, and it all starts from the reference point of the origin. So as you look at our diagram here, our origin is we're used to the origin being, but our x-axis is different than you're used to. So the x-axis actually comes out directly out from the page. And so through our origin, we now have 3 mutually perpendicular lines. And here's our x-axis. So the x is in the positive direction coming out to the page, and then the negative. And that's usually represented with a dotted line, as you see here. That's the x in the negative direction. Then our y-axis is also a perpendicular line through the origin, and the positive direction is, and what we're used to the positive direction being for x. So here's our y in the positive, and the negative direction would be in this direction here, to the left. From our last perpendicular line is the z-axis, and it is going straight up for the positive direction, and then the dotted line going down will represent the negative direction. So all of our points are will be listed in x, y, and z. So you're used to x and y, and our third dimension is listed last. So our points are x, y, and z. So if we look at our example on our page here, this one is not listed on your notes, so you'll feel free to add it or not. We're going to talk about the 3 that are on your notes. But just to give you a reference point, to start off, the point P is the x value is 2, the y value is 3, and the z is 5. So the way you plot that is you always start at the origin and first move in the x direction. In this case, the positive x 2 units, so 1, 2. Then from there, we're going to use our y value of 3, and the positive direction again, 1, 2, 3. So right there, notice how we're parallel to the y-axis here. And now we're going to be going up in the 5 units. 1, 2, 3, 4, 5. So our point P would be represented at this point here, and that would be at 2, 3, 5. And our vector, if we're drawing a vector from the origin OP, you can see the red line there, and now you can see what we're going to be working on today. But before we get into vectors, I want to make sure you know how to plot the order triple. So let's go ahead and try 3 examples. First, let's just think about how 0 would work, and it works the same way as it does with it when it's just at 2D, 2 dimensions. So we have 0, 1, 0. So first we have a 0 in the x direction, so we don't go anywhere from the origin. And then we have 1 unit for y and then 0 for z. So this point number 1 would be right here. Okay. For number 2, we have a -3 to 5. So for our x value, we're going to be going 3 units in the negative direction. 1, 2, 3. And again, our dotted line represents the negative direction. Okay. Then we'll be going parallel to the y-axis here. Let's redraw that. And so we have 2 units, 1, 2 in the y direction. And it should match up here, the 2 units here. Okay. Now we're going to be going in the positive 5 in the z direction. So one good thing when you're drawing these, a good habit is to make it look like a 3D as we go. So from here we're going up 5 in the z, so right up top. So 1, 2, 3, 4, 5. So that would be where point -3, 2, 5 would be drawn. Okay, let's see how this works in the sketch pad so you can get an idea of how the points work. Okay, so again our x-axis is here, our y-axis is here, and then our z is up the page. And all I did was I plotted our points in here, -3 for x, 2 for y, and 5 for z. And let's watch how the sketch pad draws it. So -3, and then to 2, and then up to 5. And again, the red dot is our point. This is our point that they asked us to draw on number 2. And you can see how drawing the other three-dimensional shape, as you go, helps you draw the most accurate point. Okay, I want you to go ahead and try number 3. Try to draw that point. Go ahead and draw your 3D dimensions on your page and try that, and then pause the video and come back. Okay, let's see if yours looks just like the one that the 3D sketchpad's going to draw. So now it's going the +8 direction on the x-axis. Here it's going to go 3 on the y, and then down 1 for the z because it's a -1. Okay, so hopefully your P matches the one here drawn on the sketch pad. All right, here's where a lot of your writing is going to come in handy. So on your page, hopefully you print it out. If not, I recommend to pause the video and get these items written down on your page before you listen to the discussion. Okay, so to find the distance for any vector, we're going to be able to use very similar to how we were finding the magnitude of our two-dimensional vectors. Because if we look at all of our points here, you can see no matter what point that we pick, it is also going to be at a right angle. So again, Pythagorean theorem works here in and again, completing a rectangle, a prism, or box for your points while you're drawing them or while you're thinking about distance is really helpful so that you can see that you're going to have a right angle at all these points. So when we're finding our distance of our three-dimensional vectors, we'll be using this formula here. If we want to find the distance from the origin to point P, so vector OP, we would find it by taking the square root of a squared plus b squared plus c squared. Okay. Therefore, given points A at x, y, and z, and B at x, y, z, here, so x1, y1, and z1, and b at x2, y2, and z2, the distance from point A to B is our square root of our change in our x squared plus our change in our y squared plus our change in our z squared. So we'll be, you can do it in one step or do it all together by using our formulas. In addition, the midpoint of AB can also be found by using our midpoint formula that we're used to with two-dimensional. In this case, we'll be doing it dimension, so we have x1 plus x2 over 2 to find the x value for the midpoint. The y value will be found by adding y1 and y2 divided by 2, and the z would be adding z1 and z2 and divide by 2. Okay, so we're going to be applying several concepts and operations of 2D vectors to our three-dimensional vectors now. And remember that O is at the origin, and the video is going to stop tonight at 15 minutes. The problems, I won't be able to finish all 8 problems. Please feel free to work through all of them after, and then check the second video, your answers, either just checking your answers, or if you need explanation on a certain problem, watching that part of the video. So this first one I'll do as many as I can in 4 minutes or 3 minutes, and then try the problems and then watch what part you need help with for the second part. We'll be working on IB problems in class. So let's go ahead and start with problem 1. And we have the position point A and then point B. And they want us to find vector OA. And remember, O is our origin whenever you see O. So this vector we'll be finding is from the origin to our point A, and we'll take our A values and subtract our origin, which it will be 0, 0, 0, to find this. So let's go ahead and do that. And so it will be 3 minus 0, -1 minus 0, and 2 minus 0. So our vector OA would have an x component of 3, a y component of -1, and a z component of 2. So our 3D vectors are written with x, y, and z. So you just add the z to the bottom that you're used to, the 2D vectors. Okay, number 2 and 1b is kind of interesting the way it's worded. It says the position of B from A. So understand that it's asking that B from A means that the emanating point is at A and going to B. So they actually want us to find vector AB. So anytime you see that, position vector of B relative to A is another word that they write it, or from A. They're actually talking about A is the emanating point and going to B. So now we're going to take our B values and subtract our A values to find that vector. So our B is 1 is the x, and then -3 for the A. And then the y is at 0 for B, and then subtract a -1 for the A, and then -2 minus 2. So our vector AB has an x component of -2, a y of 1, and a z of -4. Okay. And number C, we're asking for the magnitude. Remember, this is our magnitude, signaling magnitude. And our magnitude of BA would be the same as AB. So I can use those same values here. Remember our formula for the distance, the magnitude. So by plugging those in, our x would be squared, and our y would be squared, and our z would be squared, and result with the square root of 21 units. Okay, please try the other problems and get